Guys, so today we're going to be talking about, like I said, geometric terms or key vocab words associated with geometry. Trying to understand the basic terms of geometry: angle, circle, perpendicular, and parallel lines, line segments, distance, planes, points, and the like. Okay, first off, what's the point? The point has no dimensions. Okay, point is simply a location on a plane represented by a dot. You need an example. There it is. That's point A. Real simple. Just a dot. Has no really importance on its own, other than to say that it represents a point in space. Okay. A plane, on the other hand, has two dimensions that extend without end. It's often represented by a parallelogram. Okay, so it'll look like this. And the good stuff in here is plane. A plane is where everything we talked about this year comes together. Shapes are formed within a plane. We have to, without us really understanding planes too much, it's kind of how our world works, right? One of my least favorite geometry jokes is the plane is in the plane, right? Whenever you are traveling in an airplane through space, you're actually going through planes, okay? I don't know how many of you participate in sports, but when you throw, I play quarterback, when I threw footballs, we talk about the planes that we would want to throw on, okay? So you have different types of ways that you try and release the ball, depending on a certain route that we want. We talk about it in terms of planes, okay? Probably one of the most important things we'll talk about is called a line. A line has one dimension, okay? So we go from point to line, right? No dimensions, one dimension. A line has one dimension. It's an infinite set of points represented by a line with two arrowheads that extend without end. Right? When it says infinite, what does that mean? Yeah, well, in terms of distance, that means forever. When I say an infinite in terms of a number, what does that mean? So that's still kind of a distance. Infinite means as many as you can think of. There are as many points as you can think of on line. Okay, we might not define all of them, but they would go as many as you can think of. So if I started with point A and included point B and said point C is on there as well, okay, my line AC would start before I got to point A, would go to and through point A, to and through point B, to and through point C, and go forever. Okay? That's where the infinite goes, right? It does not end. It never ends. It goes on and on and on and on, my friend. Okay? So lambda. You know lambda. You lambda play along. So people started singing it, not knowing what it was. That was singing it forever. It's on okay, so, all right, that's what a line is. True or false? A line ends. False. Okay, true or false? A line does not connect any points. False again, right? It connects points, it just never ends. Okay, we define a line this way. If I have the furthest away is A, and the furthest away is C, see that? Those are the outermost points. I'll define line AC, I will write it like this. So a line over the top with arrows both ways. That means line AC. when I say line AC, that's what I'm talking about. When you get this symbol on a quiz, test, homework, classwork, that means line. Pretty good? Good so far? Line segment, on the other hand, is like a line's cousin. You still have points. You can have points in between it, A, B, and C. We'll continue with our A, B, C. Okay, but the line has two definite beginnings and ends, right? A line segment consists of two endpoints, all the points between them, all right? Okay, now, if you would imagine this, okay, what's the closest interstate to here? I-20, right? I-20. Okay. If I said I wanted to take I-20 and stretch it from across the state of Georgia, Augusta, all the way to the last town that hits, let's just pretend that it hits Tallahassee. Okay, I don't know technically how city limits go all the way down, right? But let's just say it goes from South Carolina all the way across, right? And if I said I wanted to just take I-20 within the state of Georgia, I would start in Augusta and go all the way to Tallapoosa. I would travel through Atlanta, right? It travels through Atlanta, but if I'm talking about just inside the state of Georgia, starts and stops right there. See that? That's like an example of a line segment. A line, though, right? Look at all of I-20. Okay? I-20 starts over in South Carolina. Pretend like it never ended. Pretend like it wraps around the whole world. Okay? It starts way before Augusta, correct? But it travels to and through Augusta, to and through Atlanta, to Tallapoosa, and goes beyond, right? And if you think that if it just wrapped itself around over and over down the world, you're maybe starting to get a little bit of the concept. Line segment versus line, okay? Here's how we symbolize line segment. Just like that. AC with a line over it. Okay, now, okay, AC with a line over it. Now, what is the difference, guys, between this symbol and this symbol? No arrows versus arrows, right? Okay, and it may seem small, but it's a huge deal. Huge deal. Okay, this tells me start at point A, go through anything that gets you to point C, and stop there. I have a definite beginning and a definite end. Okay, just like in my interstate example. A definite beginning, Augusta. A definite end, Tallapoosa. Everything in between on I-20, right? Here, I'm starting before point A. See that? This arrow tells me start before point A. Go to it, go through it, go to point C, go through it. Okay? All of that is a line. Right? This is where it's kind of like, the problems are a lot easier to explain all this. That's good news. Okay? Problems are a lot easier than just sitting here trying to conceptualize this. I'll get to that here at the end. Okay? Height. I did everything there. Let's do ray. Ray has one endpoint and extends without end in one direction. Let's use 3 points. How about A, B, C? Okay? I've got point A, point B, point C. Now check out what a ray does. Okay? A ray, let's just say it starts at A and extends to point B through point B, to point C through point C. Okay? Say it like that. Start at A, to and through point B, to and through point C. Go for it. Okay? All right? You symbolize a ray like this. AC with one arrow. Yes, the arrow has to go in the direction that extends forever. Okay? So I could not symbolize this the other way around. I couldn't put an arrow right here and a line, without an arrow on the other side. Got me? This symbol is a ray. Tells me ray AC, where I start at point A, go to and through everything on my way to point C and beyond. Okay. So far, so good. I mean, you got seen this before, right? Once upon a time in fourth grade before you're sleeping. All right, good deal. Okay. Now we got an angle. Angle is a figure formed by two rays or sides with a common endpoint called the vertex, plural it's vertices. You can name an angle several different ways: by its vertex, by a point on each ray in the vertex, or by a number. Okay, let's draw us an angle. Let's just go with, I don't know, angle points A, B, and C. All right. Now all of a sudden I'm going to switch up my points in a plane. Okay. Everything so far has been what we call collinear. Correct? A, B, and C to this point have all been on the same line, right? Now I switch it up a little bit. Now I'm going to put point A here. I'm going to put point B there. I'm going to put point C here. Now come on. Now seriously, I'm joking when I say this, but like, y'all see this, right? These are not on a single line, right? You got me? I cannot have a line in this way. Brings up the first point. You don't have to say the word straight line in here. Okay? You don't have to in geometry. We're just talking about geometry. All right? Do you know why you don't have to say straight line? Because every line is straight. Exactly. Perfect. There's no such thing as an unstraight line in geometry. Every line is exactly 180 degrees, perfectly straight. There's no exception, right? So when y'all say, hey, that's 59, well, literally, geometrically speaking, there's no such thing as a crooked line. It's just a bunch of little line segments connected together, okay? So if you tell me the line, it's got to be straight. You see why this cannot be a line, right? But what it can do is this. What if I create ray BA and ray BC? Okay, I've got ray BA, I've got ray BC. I just formed an angle. And this stuff in the middle right there is what we call an angle. Okay, angles are measured in degrees. We'll get into angles a few weeks from now, right? But I have several different ways that I can name this angle, right? Okay, so straight, acute, obtuse, that's called classifying angles, right? And you're going to do a little bit of that today. But I'll define those for you in a little bit too, okay? Probably next week sometime, right? For today, though, we're just going to name them, right? So if you could, if you wanted to, you could say that's angle Bob, or Fred, or Josie, or Yolanda, okay? Whatever you want it to be, all right? But we're not going to run into any angle Bobs, right? Instead, we have pretty definite ways to measure these angles, or to name these angles. Okay? First off, I can name them in alphabetical order. A, B, C. Hold on, let me go back one second. All right? What does ray BA and ray BC, what do they have in common? What's that? Okay, they're both rays. In terms of points, what do they have in common? Which is what? B. Okay, let me say this again. Ray BA and ray BC, oh, it's not straight. Ray BC, okay, they have point B in common. We call that common point of two rays the vertex, right? So when we talk about the vertex, we're talking about that point right there. Got me? Okay? That common point of the two rays, the vertex. Okay? And a vertex is simply the angle, right? It's the angle, but that's how it's easiest for us to think about angles. All right? I said I was going to name them. Here we go. First way I'm going to name it. I said alphabetical order. A, B, C. First way to name an angle. A, B, C. This angle is angle A, B, C. Just like everything else in math, we try to be as confusing as possible. Y'all remember your less than greater than symbols? Good. They're no longer less than greater than symbols. Now, this is angle A, B, C. Okay? We don't do inequalities in here. Anytime you see this symbol, you think of an angle. Okay? Sometimes they'll be really cute and do like that. Means angle. All right? Okay? Everybody with me? That's the symbol for angle. I think y'all know that. Okay? Although it's really funny because you get like EOC reviews, and I'll sit there and I'll say something like, "Hey, what's the measure of angle X, Y, Z?" And people are like, "What's that mean?" Hey, just give me a reminder. Okay? It means an angle. All right? A, B, C. Can we go the other way? C, B, A. Yeah, we can. Okay? Angle C, B, A. That works too. C, B, A. You know what? Too many letters. You can also just write angle B because the vertex tells me what angle I'm talking about. This could also be written as angle B. Right? Good so far? Hopefully this is not, hopefully it's really boring. Okay? And then, like I said, to really confuse everybody, we can number the angles. Angle 2. Okay, if I put a 2 right there, I'm talking about angle 2. There you go. 4 ways to name them. A, B, C, C, B, A, angle B, angle 2. All those can work. Right? Yes, sir. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I mean, seriously, if we wanted to call it angle Bob, we could. Okay? If I'm going to put Bob there, I can say that angle is named Bob. Because it doesn't, it's just like, you know, we make fun of this sometimes. When your parents named you, right? They gave you like a real name, correct? John, Fred, Bryce, right? You know, they could have. I mean, now you can go in there and they could have named you this. They could have written that on your birth certificate, and then I would have been like, "Hey, what's the answer?" Right? See, that's just the way that. The way we condition ourselves in math, though, is that we want to make it as easy as possible. So we'll do one of these 4. Okay? All right? It's just a symbol. It just means that vertex where those rays come together. Okay? But rather than having to say that vertex where those rays come together every single time there's an angle, say angle. Right? Good news. Last slide today. Last slide today. Parallel lines. Get back. Parallel lines, lines that do not intersect and are coplanar. Coplanar, within the same plane. Okay? Parallel lines look like this. Lines that never intersect within the same plane. I call this at line A, called that line B. They would be parallel lines when I add this symbol. Here's the symbol for parallel line. Told you, less than greater than. Don't worry about it. We're just gonna get that a year off, okay? Just gonna take a year off, and we got a whole new set. Okay. If I wanted to write that these lines were parallel, I would say, and this is where it gets weird, line A is parallel to the vertical line to line B. That means that symbol right there means parallel. Okay? Everybody with me? So far, so good? Okay, one last thing to define today. Perpendicular lines. Two lines that intersect to form a right angle. Right? And the big thing is right there. I can have intersecting lines that don't form right angles. These are not perpendicular lines. The only way for lines to be perpendicular is if they intersect and form right angles. So, talk about how to get this. Okay, if I've got two lines that intersect to form a right angle, by the way, let's get it out of the way first, second day. The box indicates the right angle, 90 degrees. Okay, the box indicates the right angle, it's 90 degrees. You will draw that so many times this semester that makes second nature. Not always. Okay, if this was line A and this was line B, I could write this, you know, our math writing here. Line A, check it out, upside down T is perpendicular to line B. Sometimes we'll have to look for boxes and simple stuff. Okay, line A is perpendicular to line B. Okay. Any questions on that? Okay. Well, I've got good news.